Now, the reason we have all this is because we want to visually also show uh, the results. Because again, we have numbers, the numbers, are they close? Are they not close? Let's go ahead and graph it. That's what makes things clearer. So let's insert, um, let's go ahead and select, we want conventional and organic, and we're only going to select our, I'm hitting control, and we're going to select our means. And let's go ahead and insert table. Okay, and there's the table. Let's put it right there so we can see it. Now there are things that we need to add. So let's go ahead and add the error bars, which is something we typically see. Um, is that right though? Organic 874. Yeah, okay, just checking. Um, if you add the error bars, okay, you click on this plus sign right here, okay, and let's go ahead and put in error bars. But we're going to have to put precise values, okay, that are related to um, our confidence interval. So here we get this format error bars. You choose custom, and we're going to specify the value. Now the value for these two things are essentially what we calculated here, okay? And we put them for both plus and minus on the top and bottom of the mean. Okay, so let's go ahead and do that again. And okay, now let's close this. Let's make our chart make more sense. So this is actually carrots. And let's also add an axis. So we know it's conventional versus organic, but let's go ahead and add the axis, which is under design. Let's add this chart element right up here. We want to add an axis title to the vertical. Okay, so this we know is yield and that was in yield, total yield in each box, and the unit was grams. All right, there we have our chart, and eyeballing the chart, we look at it and we say, well, it's pretty close. I'm not sure there's really that big a difference. How do we know for sure? Well, we know for sure by conducting something that we call a t-test. So let's go ahead and do the t-test. Now, what the t-test is, the t-test looks at differences between two groups that differ on a particular variable of interest. Okay, so in our case, the independent variable, which is the yield, okay, is dependent only upon either the conventional treatment or the organic fertilizer. Now, there are many other tests we can do, but for now, this makes sense in terms of, because the t-test will tell us, is there a significant difference between the two groups? All right, so how do we do a t-test?
So what is the t-test? Well, the t-test is one of our oldest and most frequently used procedures in statistics, sometimes called the student t-test because an article was published anonymously by a statistician working at Guinness Brewery who was looking for a cheap way to monitor the quality of stout. He used the pseudonym of student. The t-test looks at differences between two groups that differ on one variable of interest. In other words, there must be only two groups where the independent variable is being tested. In our case, we're going to compare the conventional treatment versus organic fertilizer treatment for carrots. Now, we have already a sense that it doesn't look statistically significant, but let's use the t-test to make sure. By the way, if you want to know more about the t-test and perhaps a history of statistics, there is a good, easy-to-read book that covers all the history of statistics from the perspective of the various players, the various statisticians who created all the tests that we use today. It's a fun read, and I recommend it if you have the time. Maybe good summer reading. But back to work, back to our t-test. All right, so how do we do a t-test? Well, the mathematics could be complicated, but fortunately we have Excel, unlike the Guinness Brewery statistician who had to do this all by hand, and we can let Excel crank out the t-test. All right, so let's do it. What we have to do is we have to click the data, click on the data analysis that we had installed as an add-in, and what we are going to do is we are going to look for a t-test. Let's choose this one, assuming unequal variance. It's a stronger one than the other one, so let's just use that and say OK. Now what happens then is the window comes up, the t-test window, and now we have to choose our variables. Okay, so what you do is let's go back to the data. We click there and choose, make sure you choose the label as well, conventional and all the values. That's right. Let's choose this, organic and all the values. Okay, we do have labels, so then the t-test will make sense to us. And now we have to choose an output range. The output range is, we're just going to put it right next to our pretty picture over there. Okay, so that looks right. Okay, that looks right. That's over there. That's over there. 0.05. Again, this is the our alpha. That's statistically important number, but just leave it as 0.05 and say OK. And there, we've generated our t-test. Let's see what it says. Okay, it generates again the same numbers that we could have just left it here, but no, it's better to do it by hand just to figure things out. And it tells us our count and everything, you know. Anyway, the key value we want to look at is this so-called p-value. Okay, if you've done any statistics, you know that that's something you often see in science papers. We've agreed, many people have agreed that what is statistically significant is a p-value of less than 0. Or equal to, just let's put less than 0.05, and that p-value, let's go ahead and highlight that. Oops, let me go ahead, highlight that. Right there, that p-value is not less than 0.05. So essentially what's happening is that the t-test is saying, no, there is not a big statistical differences here. So what I'll do to recap is I'll do the same work for spinach to review everything, and perhaps on the second time around it'll make more sense. All right, so now let's do it for spinach. Okay, so I'll minimize the explanation and let you follow along by watching it. Again, let's put it right here. Let's call it spinach. Because I'm lazy, instead of typing, I'm just going to copy conventional organic. I'm going to copy the conventional data. Control C. Let's dump it right there. I'm going to copy the organic data. Control C. And then let's paste it there. It's nice and gray so we can see the difference. I'm just going to use the same stats that we'll do by hand, even though we know the t-test will do it for us. The mean, the standard deviation, standard error of the mean, and the 95% confidence interval. Again, now you could see the shortcuts. I'm not going to use the formulas, the function. I'm just going to go ahead and do it by hand. It's average, and then parentheses, select the numbers that we do. We close the parentheses, enter, Control C. We copy the formula and put it in this row. Essentially, you could see here that this is just copying the same formula, just over 1. The standard deviation, same thing. Okay, let's go ahead and select that, then close it, enter, Control C, Control V. Okay, standard error of the mean. Again, we have our formula up here. So let's go ahead and just put it equals the standard deviation divided by, and I'm going to put the formulas in here so you can see how it works, square root, I know that's square root, and then we're going to use the count function because again, if you have bigger sets, you may not want to count it, you want it to count automatically, and then it selects, close the parentheses, that's it. Okay, so that's the standard error of the mean. We're lucky because we have the same number. Okay, again, that's just this divided by 2. You know, why use Excel? Because it's there. And again, we're going to use the Excel function, the confidence, to calculate the confidence interval. So again, it's equals confidence, and then it will come up. Let's just go ahead and choose confidence. And our alpha, again, is 0.05. And then you just put a comma. And then the standard deviation, we just choose from there. And then our size, just as a repeat, we'll do count again, just so that we have that. Then let's close the parentheses, we're good. Okay, now to check, make sure, you notice if you highlight the formula, that the relevant boxes, what is it counting? It's counting 1, 2, 3, 4, so it's putting 4 there. What's the standard deviation? That's getting it right. Okay, that's the good way to check. Let's go ahead and paste that back. Okay, so now we have our basic stats. Let's go ahead and make our pretty picture. Okay, so we'll make the pretty picture first by selecting the convention, control, click organic, keep holding the control key. So let's select the means because that's what we're going to map up. And let's make a pretty picture, same as the other one. Okay, so let's move, whoops, this pretty picture. Let's move it over here. Let's call it spinach. Let's go ahead and put the axis title, which is primary vertical, and that is, what is it again? Total yield per box, and the unit is grams. Okay, and let's click, oh, what happened here? That moved over somehow. Why? So let's quickly fix it, just so it looks pretty. All right, it looks centered to me. Let's just get rid of this. All right, so what's missing? Now we need to put our confidence intervals so that we can show how that looks. Again, to get to the confidence intervals, we click on the frame of the picture. They hit that plus sign, and we want to add error bars, but we want to specify the value because we calculated it. So specify value. Again, let's select the row for both, the positive and the negative, which is above and below. Which is the same thing. And then hit OK. Let's close it to see how it looks. All right, the eyeball test is telling us that yes, there is a statistically significant difference here. Okay, between the conventional and organic treatments of spinach. But again, let's make sure. Let's make sure by doing the t-test. And so let's go to data analysis. It came back. It will come back with our, it's hiding. There it is. Okay, so where is our data? Okay, so our first, we're doing conventional spinach. There. Again, click here, variable 2, organic spinach. All right, the labels again is checked off, 0.05. Now we have to tell where we want to put it. Let's just dump it there. So it's nice and even with the stuff. And yeah, conventional, organic. I'm just checking where we're going, and that's okay. And there's the t-test, and let's see if it is indeed statistically significant. Well, sure looks it. Okay, t-test is telling us that The p-value is 0.0005, which is indeed less than 0.05. So yes, there is a statistically different there is statistical difference between this organically treated versus conventional fertilizers spinach, and we know that with pretty good confidence. The sample size is small, but we're going to save that for other discussions. There are many other statistical tests that you can do, especially if you're looking at other variables, such as biomass and chlorophyll and all the other things that we measured. If you do want to compare different variables, such as biomass versus chlorophyll, you'll have to use different statistical approaches. Uh, for biomass versus chlorophyll, for example, regression may be more useful because the values are not, um, and you'll see here that essentially all those tests you can also do here. Obviously, you'd have to read more about it, um, but the point is to be pretty confident and to be able to explain our numerical data, our differences. And the eyeball is good at a first glance. The generation of basic statistics helps make it clearer, but graphing it shows people again that yes, there is doesn't seem to be a difference here, but here there probably is a difference, and the t-test gives us even more confidence that there is indeed a difference for the spinach. All right, hope that helps. Again, if you have any questions, you have myself and Jay and others around who can help with the analysis of the data that we'll gather. All right, see you later.